Hello, I'm Carly McAvoy. I'm doing word problems that we actually call these types of word problems work problems because people are working together or pipes are working together. And whenever we're doing these, we're talking about how much time would it take for something to work together or to work alone. And so we want to remember that when we're talking about time, our answer should always be positive. So you should not be getting negative answers on these problems. Pipe A can fill the pool in 15 hours. Pipe B can fill the pool in 20 hours. How long would it take to fill the pool, empty pool if it was empty, if the pipes work together? So the way I always do this is I ask myself, what could each pipe do when it was working alone in an hour? So if the pipe A can fill it in 15 hours, the fraction of the job that it's going to get done in 1 hour is 1/15. That should make sense. At 15 hours to do the whole job, every hour it gets 1/15 of the job done, assuming that it's working steadily. What fraction of the job can pipe B do in 1 hour? Well, it can do the job in 20 hours, so we're talking about 1/20. And we're interested in how long if they work together. So I'm going to say let T be the time it takes the two pipes working together. So the question is, what fraction of the job can the two pipes do in 1 hour if they work together? And this is where people get stumped. They're like, I don't know. Well, how did you do it up here? When it was 15 hours, you did 1/15. When it was 20, you did 1/20. When it's T, you should be doing, that's it, 1/T, right? So they can get 1/T of the job done in 1 hour. Since they're working together, we're going to add, and all we're going to do is set up the equation this way. What pipe A can do, what pipe B can do, and what can they do together. And that's the equation that we have to solve, which is a rational equation. I'm going to multiply everything by the LCD. The LCD here is 60T. And so 15 goes into 64 times, and you get 4T. 20 goes into 63 times, and you get 3T. And the T's cancel, and you get 60. That's 7T equals 60, and divide both sides by 7, and T equals 60/7. I'm just going to leave it there, whatever hours that is. If they ask you for a decimal, then you would divide that out. Okay, let's look at another example. Working together, you and your cousin can cut a cord of wood in 5 hours. Working alone, your cousin can do the job in 7 hours. How long would it take you if you worked alone? So we know together you could do it with 5 hours, and your cousin could do it in 7. How long would it take you if you didn't have your cousin helping you? What fraction of the job can your cousin complete in 1 hour? Well, your cousin working alone could do 7 hours total job. So in 1 hour, the cousin can do 1/7 of the job. She's working pretty fast. What fraction of the job can you and your cousin do in 1 hour? Well, we already know you and your cousin working together take 5 hours. So in 1 hour, you're going to get 1/5 of the job done. And finally, let T equal the time it takes you to complete the job alone. What fraction of the job can you do in 1 hour? Again, just like the last one, if we know it takes T time in 1 hour, we're getting 1/T of that job done. This one's a little different because we're adding together what you and your cousin can do, and we're setting it equal to what you do together. So be careful here. It's actually 1/T plus 1/7 equals 1/5. So together, your 2 times together equals 1, what you're getting done in 1 hour. So the least common denominator for that is 35T. So I'm going to multiply everything by the LCD. The T's cancel, and I get 35. 7 goes into 35 5 times. 5 goes into 35 7 times. And then I'm going to move that over by subtracting 5T, and I get 2T. And divide by 2, and I get 17.5. Or they might ask you to leave it in fraction form, which would be perfectly fine, right? That's, you're slower. Cousin is showing you up in a big way, and you should be ashamed. Okay, moving on. Working together, 2 copiers can complete a print job in 8 hours. Whoops, that's not where you can see it. There we go. The old copy machine takes 12 hours longer than the new machine if they work alone. If it works alone, that's what I should say. If they each work alone, the old one is 12 hours slower than the new machine. Okay. How long would each machine take to complete the job alone? Well, let t equal the time that it takes the new machine to complete the job alone. So we don't know how much time it takes for the new machine or the old machine. But I'm saying let's let t equal the time it takes for the new machine to work alone. Then what fraction of the job would the new machine get done in an hour? Hopefully by now you're feeling that one, 1 over t. How could I describe the old machine without bringing in a new variable? Well, it takes 12 hours longer than the old one. So we're going to describe that as t plus 12, the time it takes the old machine to complete the job alone. It's working much slower. What fraction of the job can the old machine do in 1 hour? Again, we're just taking its time and putting a 1 over it. So now we have 1 over t plus 12. What fraction of the job can they complete in 1 hour working together? Well, we were told it takes 8 hours, so we know that's 1 over 8. So our equation for this one is going to be 1 over t plus 1 over t plus 12 equals 1 over 8. And so we have to multiply again by the LCD. And the LCD here is a standalone t plus 12, whoops, and the 8. So we're multiplying everything by 8t, t plus 12. And then over here I can see the t's cancel, and I get 8t plus 12. Here the t plus 12's cancel, and I get 8t. And here the 8's cancel, and I get t plus 12. Hang on a second, I think I forgot to freeze my, yeah. Okay, so now I'm going to distribute to simplify or solve that. And I'm going to get 8t plus 96 plus 8t is t squared plus 12t. Since I have something to the second power, I want to move everything to the other side. So I have, can you see I have 16t plus 96. So I'm going to subtract 16t and subtract 96 over here and get t squared minus 4t minus 96. And that's what I'm going to try to factor to solve, remembering that I can't get a negative time. So what are the factors of 96? I don't know. 1 and 96, that doesn't get us to 4. 2 and 48, that doesn't help us. Does 3 go in here? Yes, 3 goes in here 32 times. 632, yeah. Does 4 go? Yes. 24 times. Does 5 go? No. Does 6 go? Yes. 16, that's still no good. Does 7 go? No. Does 8 go? Yes. 8 goes 12 times. 8 and 12 are 4 apart, so that looks like my combination. You might be a little faster at that. Sometimes I just have to work my way through it. I have 8 and 12. I want this to be a minus 4, so minus 12 and plus 8. I'm going to set each of those equal to 0. T is either negative 8 hours or T is positive 12 hours. Well, we can't have a negative time, so that makes no sense for our scenario. So T, the time it takes the new machine to work alone, is 12 hours. That means the old machine is 12 hours slower than that. It actually takes it 24 hours. So it would take the old machine 24 hours to complete that job. All right, I'm almost running out of time. I'm trying to keep my videos under 10 minutes. What if we had two things that were working against each other? How would that change our problem? Well, here's the first problem we did. Pipe A can fill in 15, pipe B can fill in 20. How long if they work together? What if we change that original problem to pipe A can fill it in 15 hours, pipe B can drain the pool in 20 hours. So they're both not filling. One's filling and one's draining. How long would it take to empty the pool if it was full and both pipes were open? Well, we're going to fill the pipe at a rate of 1/15 an hour. We're going to drain at 1 in 20 hours. So this is, it would never drain, right? Because see how it's draining slower? 1/20th is a smaller number. It's draining slower than it's filling. So it would never, if we had that particular problem that I made up there. How long would it take to empty the pool? How long would it take to fill the pool if it was empty? So what we're doing was we're putting some water in, we're taking water out. We don't want a negative, so if we say the total time here was T, then it would be 1/T, right? But what we're saying here is that they're working against each other. So I have the pool filling and I'm subtracting off because I'm taking water away as it drains, and then I equal 1/T. So that changes the problem, right? I can multiply this whole thing by 60T and I get 4T minus 3T equals 60, and 4T minus 3T is T equals 60. So it takes 60 hours to fill the pool if it was empty to start with. I know it had to be filled because I could see that it was filling faster than it was draining. And it's a subtraction. That's how it changed the problem. If we have working against each other, we subtract. Have a fantastic day.